All right, so we're going to do a little bit more work with this logging data. And specifically, we're going to look at how to kind of read and compare these box plots. So this is part B on the notes. And you're certainly welcome to pause the video and give this a try on your own and then watch it through and see if you've gotten the right answers, or if you just feel like really confused about how to proceed with these, you're just welcome to play the video straight through. So let's take a look at these. First question says, which group has the greatest number of trees per plot? So the greatest number of trees would be the max. And so when I look at these box plots and I look at the max, the middle graph has the max of 20. The graph for group 3 has a max of maybe 22. And the max for group 1 is about 33. So that would be the biggest max or the greatest number of trees per plot. So that would be group 1. All right, question 2, which group has the least number of trees per plot? And so people sometimes get stuck on this one, whether it's group 2 or group 3. And I think that's because of the outlier. So the outlier is a valid data point. And so it is the lowest thing on here. So that would mean that group 2 is going to be the one with the smallest min, or the least number of trees per plot. So it's kind of the opposite of the first question. At question 3, which group has the smallest median? So the median is the line that splits the box into two pieces. So we're looking for the lowest value one. So the median for group 1 is maybe about 23. The median for group 2 looks like maybe about 14. And then the median for group 3 is maybe 18. So the lowest bar here is going to be group 2. So group 2 has the smallest median. All right, question 4, which group has the smallest variation? Okay, so we're looking for the most compressed box, would be the smallest variation. And so if we kind of measure these out, the green one looks like it goes from about 16 to maybe 33. So it's got a length of 19. If I look at group 3, so the one on the far right, it starts at maybe 4. And it goes to maybe about 21 or 22. And so that'll be a difference of about 18. And then the orange one as well also looks like it's about 18. So how do I decide which one has the smallest variation, or do I just call it a tie? And so in this case, I would actually pick group 2 to have the smallest variation. And the reason for that is that all of the data except for 1 point is all kind of clustered together. So if that outlier wasn't there, then this thing would have a range of maybe 11. And so then that would make it the most kind of compressed box. And so since I only have that single outlier, I would say that this one is the one with the smallest variation. Because you just don't know how many of the data values are sitting in the whisker for group 3. Right, so that was question 4. And then question 5, it says which group is the most consistent? So we haven't really talked about this idea a whole lot, but consistent means that it has the smallest spread. So you're getting kind of the same values. So if I were to say that you were consistently a good student, that means your scores are probably, you know, in the B's, B pluses, A minus. So you're kind of clustered around that B plus, A minus average. Okay. And so consistent is also the same idea as the smallest variation. So that one would also be group 2.